Hello and welcome back to Ganesh Institute. So in this video, we are going to talk about the introduction of group theory. So we will talk about a few definitions and terminologies which are required to have basic understanding of group theory. Okay. So let's get started with the first terminology, which is algebraic structure. What is it? Algebraic structure. Okay. So just see this. I have written here this. Now it is enclosed in parentheses. First thing is the type of the number, natural number. And this is the operation. That is addition. So algebraic structure is basically a non-empty set. It must be having an element at least. So it is a non-empty set with binary operation. It may be addition, subtraction, multiplication, or whatever. So you have one or more binary operation. We cannot only write it or show it using plus. We can use asterisk, O, and whatnot, maybe dot. Okay. So it may have one or more binary operations defined over it. Okay. And it has to satisfy a property, which is a closure property. Now, you must have read this property in your, lower classes, lower standards. Tell me, what do you mean by closure property? For example, this is the set of natural number, right? 1, 2, 3, 4, and so on. If I have taken natural and plus, okay? If I take any two elements, 1 and 2 maybe, and I apply this operator, I'm taking the elements from first set, natural number set, and I'm using this operator plus whatever is being given in algebraic structure. And if I add, what have I got? 3. Does it belong to the set itself? Yes, it is a natural number. It belongs to the set. That is this one. So we will say that it follows closure property. Okay. Have you got it? So in closure property, we have the element. For example, if I'm having an element A and another element B, and I'm having the algebraic structure as this, for example. So if I'm saying there is an operation happening in between these two elements, these two elements have been taken from this set, that is, they belongs to G, any set, okay? So the answer of this operation must be from G. That is, always the answer which we will get has to be from this set. Then we will say that A and B follows closure property. Okay. Now, this algebraic structure, which is following closure property, that is called as groupoid. What is it called? Groupoid. So, groupoid can be any set, a non-empty set, having the binary operation as star. Then this algebraic structure is a groupoid or quasi-group. If and only if we are taking A and B from this non-empty set, and the result of the operation is giving an answer from the set itself. Okay. Now, let's say you are having another property. We are moving towards next property, which is associativity. So you know very well what is associative. When we have, let's say, A star, B star, C, A star, B star, C. We are having, firstly, we are operating A and B. Then whatever result will come, we will operate it with C. Or we can change the order. We will first solve B and C with the operator and then solve the result with A. Then if the result comes out as equal, then we will say that these are associated. This is following associative property. Okay. For example, if I'm considering again a non-empty set, natural number set, and I'm having plus operator. Okay. Addition operator. So you can take any three members from this set. Let's say 1, 2, 3. If I add them in these two things, just bear with me. So I'm having 1 plus 2 plus 3. What is it? 1 plus 2 is 3. 3 plus 3 is 6. Or if I change the order, 1 plus 2 plus 3, I'm adding 2 plus 3 first. So 1 plus 5, that is 6. Both are equal. So that means plus this algebraic structure is associative. So whenever an algebraic structure, we are talking about the binary operation addition here. So addition is of natural number. This is a set. Is following closure property? Yes. Is following associative property? Yes. When it follows only closure, then it is a groupoid or quasi-group, that algebraic structure. And if it follows closure and associative both property together, then that algebraic structure is called as semigroup. What is it called? Semigroup or demigroup. All right. So whenever we have a non-empty set, let's say G, and a binary operator star, such that we have elements A, B, C from the set, and the result of A, B, C operating under the binary operator star, and they are equal, and they are following closure property as well, then the G star, this algebraic structure, is called as semigroup or demigroup. Is it fine? So we have talked about groupoid and semigroup so far. Now the third. For third, we have to understand next property after closure and associativity, the third property, which is existence of identity. Existence of identity. Now, what do we mean by identity? Okay, let's say I have natural number and plus. And here I have natural number and multiplication. And multiplication. These are two algebraic structure, okay? Now let's see whose identity exists. I have taken an element, let's say 1 plus 2, okay? 1 and 2 are two members from the non-empty set natural number. Same here, 1 and 2. Here the operation is addition and here the operation is multiplication. What have you got as an answer? 1 plus 2 is what? 1 plus 2 is 3. Yes. 1 plus 2 is 3. And 1 multiplied 2 is 2. Correct? Now tell me, what should I have? This is the result, right? If you have A and you have another element E and you apply any operator and you get the member itself, then this is called an identity. So for example, here I have this algebraic structure as plus. I have considered A, any number, 1, What should I add so as to get 1 only? 0? Yes. So can I say 0 is the identity? 0 could have been the identity, but the thing is, it must be in this group. Does 0 belong to n? No. Natural number starts from 1. So in under addition operation, natural number does not follow the existence of identity. Okay. Whereas if I talk about the integers, just forget about this bit for a moment. Integers, z, and again I'm having plus. So consider any number from integers. Let's say -2. What should I add so as to get -2 only? 0. Does 0 belongs to z? Does 0 belong to z? Yes. So 0 is following this, is an identity for this algebraic structure. Okay. Have you got the identity thing? So for identity, operator should be applied to the element from the set, and that thing is called identity. That number is called identity, which will give us the number back. Okay. So that means z plus this algebraic structure is having identity's existence, whereas n plus does not. Whoever has got existence of identity, whichever algebraic structure, let's say G star, where G is the non-empty set and star is a binary operator, that is the operator between two elements. So that is having an identity, that is a member A which belongs to G, and member E also belongs to G, and A star E is giving us A. Okay, or we can say E star A is giving us A. Then we will say E is the identity. And in that case, that means whichever algebraic structure follows three things. It is closure, it is following associativity, it has existence of identity, that algebraic structure will be called as monoid. What it will be called as? Monoid. So closure is the basic thing. Algebraic structure is called algebraic structure because it is closure. But what about these two? If it is only associative apart from closure, it is what? Semigroup. If it is only closure, that is algebraic structure, which is groupoid. If it is groupoid as well as associative, then it is a semigroup. And if it has existence of identity as well, then that algebraic structure will be considered as monoid. Okay. Let's move on to the fourth property, which is existence of inverse. Existence of inverse. So in inverse, the property is like, if this is an operator, you have two members from the non-empty set AB, then they should give you E, the identity itself. Okay. Okay. Whether you are operating B and A or A and B, it should give you identity, then B will be considered as inverse of A. For example, if I talk about Z plus, okay, integer and plus, I am considering two elements from this set. Let's say 1 and 2. Okay, let's leave this 2. I have operator plus here. This is element, this is operator plus. What should I have here so that I can have identity. What have we got as identity? What should be added? Identity is when a number is there, what should be the operator in terms of operator, what should be added here to get the element, which is 0, and 0 belongs to Z. So 0 is the identity for this algebraic structure. So that means I should write here some element so that I can get algebraic, so that I can have identity. Tell me what is it? Then the member will be of opposite sign. Only if I take any member here, 2, I should be having opposite sign, the element itself with opposite sign, then only I can get identity for this algebraic structure. Let's say if I have -3 belongs to Z, integer set. Then what should be added? Because it is addition operation, this is the algebraic structure. What should be added to get identity? This is 3. So every time this also belongs to Z, correct? So that means we have existence of inverse for Z plus. So this algebraic structure, that means an algebraic structure of the form G star, where G is a non-empty group, star is any operator. If there is a member B, which we will call at inverse, belongs to Z, such that any member when gets operated with B gives you an identity element, then that is called as inverse. And if inverse exists, what does it mean? That algebraic structure is group. Okay? So, for a group, what should we have? Closure property. Every algebraic structure is closure. That is, it will definitely a groupoid or quasi-group. Then if it shows associative property, both of them combined together, groupoid plus associative. What is it? Semigroup. If it is closure, associative, and it has identity, then combining these 3, it will be a monoid. That is groupoid as well as semigroup plus existence of identity is monoid. If it has inverse as well, that is closure, associative, identity, inverse together, it will be a group. So have you got the terminology for a group? Group can be any algebraic structure following 4 properties: closure, associative, identity, and inverse. Okay? Now one more thing, which is the final property, the commutativity. The commutative. So you know commutative, right? If I have n star, G star, any non-empty set and a star, then we will consider it if A star B is equals to B star A. 2 plus 3 is equals to 3 plus 2. So that means natural number under addition property are commutative. But because they do not follow the identity, so we cannot consider them the group. Yes? Group has to be all those properties, 4 properties we talked about. But if one more property is added, that is, if a structure is closure, that is groupoid, if it is associative as well, that is, it is a semigroup, if it is having existence of identity, that is, it is a monoid as well. If it has existence of inverse, that is, it is a group. And then if it has commutative property, then it will be considered as abelian group. Getting my point? So 5 properties: closure, associative, existence of identity, existence of inverse, and commutativity. These 5 properties make an abelian group, make an algebraic structure an abelian group. Got it? So this is it for today in the introduction of group theory. Hope you have liked it. And if so, then don't forget to like, share, and subscribe our channel. Till my next video, take care of yourself. Bye-bye.